the eighth, right? Okay, so we're given a function f of x, which is the fourth root of 1 plus 2x, and we are asked to find the linear approximation. Of course, near 0, this, near a. And I know that f of x is approximately a linear function near a as f of a plus f prime of a times x minus a. This is very similar to that delta y being approximately dy. In this problem, the function is given to us, a is given to us. Let's differentiate the function because I need it here. So when I differentiate, so this is f of x 1 plus 2x raised to 1/4. Do we agree with that step? Perfect. So now I have to find f prime. Remember the chain rule, 1/4, 1 plus 2x to 1/4 minus 1, which is, excellent, multiplied by the inner function prime, which is 2. So then the simplified form is 1 over 2, because I simplified 2 and 4. The fourth root of 1 plus 2x to the third. Do we all agree with this f prime?
To the third,
3/4.
or the inside the
To the third. It's power 3/4, 3 over 4. The denominator is the index, and the numerator is the power.
Gotcha.
Okay. So now I really need f prime of 0. So then f prime of 0 will be, this is 0, 1 cubed is 1, the fourth root of 1 is 1, so the answer is indeed 1/2. Do we agree with that? So now I put everything together. The left-hand side will be replaced by the original function, the fourth root of 1 plus 2x approximately. F of 0, I hope we agree that f of 0 is 1, right? So here I can determine f of 0. 0 plus 1 is 1. The fourth root of 1 is 1. So then f of 0 will be 1 plus 1/2, and x minus 0 is x. So I will say this is the linearization of this function. What does this mean? And then we'll go to the second half of the problem. What does this say? This says this, that near 0, not 1, not 1, and not -1, those are too far away. Near 0, if you want to evaluate the fourth root of 1 plus 2x, you can use this confidently. It's okay. You're going to get very close. But if at 0 you want to evaluate at -2 using this function, you're going to get a huge error. If you want to evaluate this function at +2, not a good approximation. But if you want to stay around 0, you're going to get a good approximation with 1 plus 1/2 x. And of course I want that. I don't like this function, do you? I like this function. Much easier to work with. Now here's the second half of the question. Find the values of x for which this approximation is within 0.01 or 0.1 of the actual value. So we want this approximation so we want to find correct me if I'm wrong when I write this, Noah. Find x such that 1 plus 1/2 x, this approximation, is within 0.1 of
Actual value.
0.1 of,
Says,
just to make sure, I just want to verify.
It says,
I understand.
and determine the values of x which the linear approximation is accurate to within 0.1.
Of the actual value it should be. So then determine, verify the given linear approximation, okay, we did. Then determine the values of x for which the linear approximation is equal to within 0.1 of the actual value. In other words, of the true value. It should say that. So find x. In other words, how far can I pick x from 0? How far I can pick x from 0 so that the function, the distance, the absolute value, between the function minus the approximation in absolute value is less than 0.1. So the actual value minus the approximation is less than 0.1. Okay, let's think about it for a moment. So find x, how far I can pick x from 0 to the left and to the right. Because I can't guarantee that negative 0.5 will give me an approximation, will give me an error less than 0.1, right? So it says find x such that there is not more of an error than 0.1. So the true minus the approximation in absolute value, because I can be on this side of 0 or I can be on this side of 0, so the absolute value is a distance, is less than 0.1. So now this inequality changes into negative 0.1 less than the fourth root of 1 plus 2x minus 1 minus 1/2 x less than 0.1. And the only thing I can get rid of is by adding 1, and I cannot get rid of anything else. So when I add 1, I get 0.9 here, the fourth root of 1 plus 2x minus 1/2 x less than 1.1. We're not capable of solving such an inequality. We have to use the graphing calculator for this. We will be able, actually in chapter 4, we will be able to solve. So first I have to solve the equation. Number 1, the fourth root of 1 plus 2x minus 1/2 x equals 1.1. I have to solve this and get a number. And the second equation is the fourth root of 1 plus 2x minus 1/2 x equals 0.9. So I have to solve this equation. I'm not changing the inequality symbol into an equation. I need to determine those points first. Okay, so let's put this in the graphing calculator. So clear, whatever. So I'm going to put only one function, or we can put two functions. It doesn't matter. Okay, so we have 1 plus 2x, close the parenthesis, caret, and you know me, I don't like those fourth root, and then minus 0.5x. So I put in the left-hand side of the first equation. I can subtract 1.1, or I can consider 1.1 as the second function, and I will change the viewing window to standard, see what happens. That's one function, and here's the other. Okay, very difficult to see what's happening here. So I have to zoom in and look on the right-hand side of 0. Or I can just go back and change this and just look at the 0. Let's leave it as is. Okay, I have that. So let me just change the viewing window a little bit. So let's say between -1 and 2 with a scale of 0.5, and between -2 and 2 with a scale of 1, and let's see now. That's one function. And now the horizontal, oops, uh-oh.
You didn't type in -2 for your window.
This is what I did.
Sorry, guys.
What did I write? Yeah, I write 0.5. So minus 0.5x.
Your window, I think you messed up typing in your window.
Like it doesn't intersect, so.
Yeah, the problem is that they don't intersect. That's the problem. Okay, y minimum. Okay, I see what you mean, but it's still. Huh.
It intersects for 0.9 though, at like 2 spots.
Okay. So this equation has no solutions. Right? It doesn't. I mean, I don't have to change the viewing window. It's very clear, right? Okay, perfect. Let's look at the other one then. So the other one equals 0.9, so I'll change this into 0.9. Okay, and graph. So 0.9 is right here, and it crosses in 2 points. Okay, so I'll change the viewing window again. I don't really need this much of a negative. So I'm going to put -0.5 so I can see that better. Not that I need to, I just wanted to see it better. Okay, perfect. So there are two intercepts, one here between -1 and 0, and the other one here between 0 and 2. So let's find this intersection. So second and intersect, right, number 5, between -1. Was asking me about something else. So 5. Yes, that's the first curve. Yes. That's the second curve. Yes. And the guess. Okay, my guess is -0.9. Because it doesn't know which one I want, so it's asking me for a guess. But I said negative. Didn't I say negative?
Yeah,
Why did it give me the positive?
it gave me the same thing when I put -1 in.
So that's the first curve. That's the second curve.
I was watching that anyway.
Yeah, I'm gonna drag it. So this is -1, this is -2, correct?
Yes.
Okay, so I'm gonna put -0.8, please.
When you're selecting the curves, you have to select the 2 on the left side. Like, you want to go to that one?
It doesn't matter. So I'm selecting a guess, which is -0.9. Why does it give me the positive solution?
When you chose to pick the curves, you picked the 2 that were next to the right intersection. You have to pick the 2 on the left. So when it says first curve, you have to scroll all the way to the
But
left.
it doesn't matter. It still has to give you, yeah, that's fine. I'll do that, but it doesn't matter. I've never experienced this problem. Okay. Maybe the software is like that, but let's give it a shot. Once I give the guess, it should give me this intercept. So anyway, so this is the first curve, enter. The second curve, yes, enter. I want to guess -0.8.
I just scroll over and press enter.
So did you find the other one?
Yeah, I got negative point.
Okay, we trust you. So there are two solutions here, x equals negative
0.3689.
3689, and the other one, so that's x1 on the left and x2 on the right,
Got 0.677669.
0.677669.
Yeah.
Okay. Very good. So in order to solve this inequality, now we have an interval between negative 0.3689 and 0.67769. So the question was, find x such that the error between the actual and the estimate is less than 0.1. So for the error to be less than 0.1, so the other picture was we had the y, it did not intersect, so let me also add that so we can see the whole picture. The 1.1 that was not an intersection, which is fine. So in order for the error to be within 0.1 between the actual and the estimate, then we have to pick x between negative 0.3689, between this point, I'm assuming that this is correct, this number, because I couldn't get it. I can put it in my calculator. And this number, which is 0.67769. That's where we have to pick x. If we go outside, if I pick, for example, let's say this was 0.6, if I pick, let's say, 0.9 or, what did I have here? Yes, 0.5, yes, correct. So if I pick, let's say, 0.9 and put it in the inequality, you will see the error will be greater than 0.1. So let's do that. So if we pick anything outside of this interval, so this was 0.67, right? I'm going to pick 0.8. So for x equals 0.8, I have the fourth root of 1 plus 2 times 0.8 minus 1 plus 1/2 times 0.8. And let's see what we get. I guarantee you that we get a number greater than 0.1. Because we are outside of that interval. Is that clear? Noah, is this better? Okay, I'm so sorry, but I could not determine with the software those numbers. I can use my calculator at the end of the class and I can look again and make sure. But that's why I want to see that, let's say, with 0.8. So I have, in parentheses, 1 plus 1.6, so that's 2.6, but anyway, I wrote it. Power, right? 1 divided by 4, the fourth root. And then minus, I did not put the absolute value, so whatever I get, it has to be an absolute value. But I'm on the right-hand side, so it's going to be, it could be either way. So parentheses, 1 plus, but remember the absolute value should be there, 0.4. So when I click enter, I have to get a number either to the positive, it's the absolute value, so I get a number greater than 0.1 because I did not stay within the range of negative 0.3689 and 0.67768. That's why the error is bigger than 0.1. It's not that much bigger, but it's bigger. It's the error is in absolute value 0.13017. Is this okay?
So when it asks to enter the answer in interval notation, the interval would be
That's what they
negative 0.36.
Yes.
Yeah,
And do not use brackets.
don't use brackets.
Because no, let me tell you why. It says strictly less than 0.1.
Oh, so it's
It
not
doesn't
included.
say 0.1 or less, does it?
No.
In the question. It says within. So I will not put brackets because within does not mean equal to. So I will use exactly the answer that I wrote. But before you enter, I would just make sure that you have the 4 digits because they want 4 decimal digits. And I will verify that solution one more time. It's not that I don't trust you, I do. I just, I couldn't verify it with the software. Good, very interesting problem, very good question. Good, so let's go back to this and finish it up, and then we'll look at more problems for the review. So we decided to have the test a week from today. Next Tuesday, okay? Okay, so what I recommend, we're gonna go through this, we're gonna review today more and more. And on Thursday, I would like to answer your questions. So make sure you try to finish up WebAssign and bring in anything that you would like to work on. And then I will have to start chapter 4, if there is time, of course. Chapter 4 is not on this test on Tuesday. Chapter 4 is very interesting, and it's a long chapter. Yes, chapter 4 deals with applications of differentiation, including maximizations. Yes, finding functions and finding their maximum. Including Newton's method, which will allow us to solve these equations in a blink. Any type of equation. Okay. Anything else from me? Is there anything else you worked on? Anything else you would like to determine or look at or anything? Okay, so we only covered the last 1, 2, 3 problems from here. So let's continue with whatever you want. Now you can say I don't want to do this, and we can choose other problems. Would you like to continue with this? Yes? Okay, so let's work on the first problem for 2 minutes. Be careful, you're getting an I just did, and I sent it to the our IT department. Do not open any emails that you know are kind of weird. You're getting a lot of phishing. From my mail, .acc.edu, I just got one and I sent it to the boss, and the boss said, I said, Tiha, this is our high-tech guy. I got this and did not touch it. Very suspicious, I think. Thanks. Wise choice. Please delete the email. Do not click on its links. So it was something from my mail. So be careful. Who knows what that is and what has in it. So please do not open attachments. Don't click on links. Don't. Let me know when you are ready. I don't want to waste time. I just want to cover as much as we can. So tell me when you're done with part A. How do you have this? Oh yeah, that's fine. Yes, of course. Yes, of course. Anyone?
I have a question.
Yes,
For chapter 3.7
yes,
and 3.9,
yes.
is that more of, like, I know this is like the practice test and you do the test
We're
every
just reviewing with this, yeah.
Is that for the WebAssign questions would be based on something like the outline that they have for the WebAssign homework, as far as like the questions on the test?
Yeah, they're pretty much the same. It's the publisher of the book.
Okay.
So they're pretty similar, yes.
Okay, alright.
Okay, can we start working on this problem together? Or we need more time? Do we need more time? Yes? Is that a yes or a no? Okay, so how do we proceed? What are our choices here?
Take the line of it.
Yes, it's the only option. Natural log y equals sine x times natural log x. It's a function raised to a function. We cannot apply any formula. We have no formula for this. This is the one that we have to apply natural log to both sides. There is no way around it. And only now we can differentiate both sides. So when we differentiate the left-hand side, we write, yes, 1 over y times dy over dx equals remember, this is a product. We have to use the product rule. First function, second function. Careful.
Cosine
Yes, indeed, cosine x.
and line x.
Very good. Plus,
Sine
X.
over x.
very good. Over x or just times 1 over x, that's fine too. So dy over dx, I have to multiply both sides by y. But I will not write y because then I have to change it into x raised to sine x. And then I copy the rest. And this is it. So please make yourselves a note, a function raised to a function has no formula. And I have no choice but apply log first and then differentiate. Is this okay? Okay. Let's work on the next one. We have tangent cubed of sine x. When you're ready, let me know. And please review everything. We're going to have a little quiz on Thursday. Open notes, open book. Ready? Anyone? 3. Tangent squared of sine x times secant squared of sine x times. So of course you know me. I ran out of room. So 3 tangent squared of sine x times secant squared of sine x times cosine x. Do we all agree with this? Okay, perfect. Next one. Y equals sine inverse 1 over x. Remember, this is not 1 over sine. This is arc sine 1 over x. So let's differentiate this 1 minute.
We use the chain rule for B, right?
For this one?
For B.
Yes. Yes. So I had a lot of functions here. I had power 3, I had tangent, and I had sine. I have to start with the power, then I differentiate tangent, and then I differentiate sine. Is that okay, everyone? Chris, are you okay? Justin, are you okay? Do we need more time for this one?
Is this a
Yes.
logarithmic problem?
No, careful. This is an outer function and an inner function. When we differentiate arc sine, we get 1 over the square root of 1 minus this squared. And then we differentiate 1 over x. And some time ago I said, please remember this, 1 over x prime. Very important, you'll see why in chapter 5. So when we differentiate 1 over x, what do we get? Yes, please try to remember this one. You can say, it's so easy that I can always find it. That's true. But it will save us time. I will try to simplify a little bit, because I have negative 1 over x squared, and the square root will become x squared minus 1 over x squared. And I should write minus 1 over x, and this is the square root of x squared minus 1 divided, it's x squared over x. And then I'll simplify one of these two. So I recommend this form, x the square root of x squared minus 1. Yes, Eddie?
Can you do another problem like that, but without 1x?
Without 1 over x,
Yeah, could you do another
a
one?
different function?
Yeah.
Yes, of course. So let's take a look. Any questions on this?
How long the test to get the simplified down that much?
Well, normally, if it doesn't say do not simplify, then I'm expecting you to simplify it. So most of the time I do write, because I don't want you to waste your time. So here it says do not need, no need, no need, no need. So when it says simplify, for example, here I said fully simplify the final answer. So because I want to cut back on time, right? I want you to go through the entire test and not focus on something and waste time simplifying it, and it's not even simplifiable. So I would put it in writing if I'm interested in a full simplification. Okay, so we're trying to find, let's say, arc sine of 4x squared. We want to differentiate this. Let's work on this for 1 minute. Yes,
For the 2x squareds, how did
but
it?
no, when I take the square root from x squared, I just get x. Oh, yeah. So, yes, so you have the square root of the top and the square root of the denominator, which is x. So then x squared divided by x would be just x.
X squared minus 1, this one simplified because it's a function. Or
No, you
Um,
have the square root of the top over the square root of the denominator. So the square root of this stays, but the square root of x squared, so you have to extend the square root all the way.
Okay,
The square root covers x squared as well.
okay. Alright, I got you.
So when we differentiate this, we will have 1 over the square root of 1 minus 16x to the fourth times, thank you, times the inner function prime, which is 8x. You can put it at the top or you can put it on the side, the same thing. Any questions? Eddie, is this better?
Yeah.
Okay, so we have now f of x sine x times the square root of 3x minus 1. Okay, 1 minute. I hope you recognize that this is a what?
Product?
A product. So you will have a sum of 2 products.
Should we turn that to 3x minus 1 to the 1/2?
It's okay, however, I would not do that only because it's a square root. If it were the fourth root, yes, I would have. But since it's the square root and we know this formula, we know that the square root of f prime is 1 over 2 the square root of f times f prime. Why bother to change it into 1/2?
Okay.
Because eventually I'll get x, the function to negative 1/2, and I still have to bring it down and take the square root. And so if it's the square root, I'm fine. If it's the cube root or the fourth root or any other root, I will change it. We have an answer for this one, or not yet? Yes?
Cosine x
Cosine x,
times 3x minus 1.
very good. The square root, very good. Plus,
Sine x times 1 over 2, and then square root of 3x minus 1 times 2.
that's it. Very good. Any questions on this? So let's look at y equals hyperbolic tangent squared of hyperbolic cosine x. Okay, 1 minute. Any questions? Eddie, are you okay with the previous one?
I just wanted to know where you got the boost on that.
I should have put it in here. The inner function prime,
All the time.
what I put it there,
Okay.
because I'm lazy. Yes, Noah?
I just have a quick question for the
Yeah.
question I had.
Yes.
So you say on 2, 5, 3 down, can you cancel this
Yes.
out with this because it's all?
No, this is not multiplication, it's a
Oh,
difference.
it's subtract, okay.
So you have to completely factor before you simplify. Very careful. That is a very common misconception that, I can simplify, but if it's a sum or a difference of terms, that particular portion of a term is not a factor. Okay, do we have an answer for this? For y prime. We have 3 functions here. We have the power, we have tangent, and we have cosine. Of course, hyperbolic tangent, hyperbolic cosine. 2 times,
And 8.
Yes. of cosine x
Times secant h squared.
secant h squared of cosine. And times, you're not surprised, right? Times hyperbolic sine. So it's all a product, no addition, no subtraction. please. It's very easy to make an error. I don't wanna see sum or difference when you apply the chain rule, right? So it's 2 times tangent of the cosine times tangent prime, which is secant squared, times sine, given a function phi. Questions? Okay, so all your favorite now, x sine y equals natural log x squared minus 2x plus 4y cubed. Well, let's take a minute and a half on this one. Okay, 2 minutes.
That's natural log of x squared minus 2x.
Yes.
Okay.
It's on that form.
Oh, it is.
It's the next problem. Did I skip?
No, I just didn't realize it. I wasn't paying attention.
Yes, right?
I was wondering with that problem if we can do this,
Yes, of course.
but it was not asking for the derivative of y, it was asking the derivative of x.
Are both x and y variables? I'm sorry, are both x and y functions of something?
Well, this is the implicit differentiation.
Right, but are we asked to determine dx
Yeah.
over dt, or what are we asked?
It's not. I don't think it was dx over dt.
So they're saying now that the variable is y and the function is x.
Right.
So is x a function of y then?
Honestly, I don't know.
So is it a different way of a sign?
Yeah.
What if I bring it up and you take a look at it?
Okay.
Let me just take attendance because I was just getting there.
Okay.
Andre, Eric, Chris, Hein, Noah, Sarah, Greg, Kyle, Jacob, Josh,
So
Sam.
the one above I did was kind of like it.
Yeah, I'll bring it up. Then you bring it up for us. Okay, it's ready if you want to come up.
Okay.
Yes.
So I think you use
Yes.
in this, but you always start at 0, or would you start at 5?
It depends on what it says about t.
Which is kind of-
So, yeah, so I should have written t here. Because normally we look at the particle, although it's possible that I'm looking at the particle only after 3 seconds after it starts moving. So it's very possible, but we normally look from the moment it starts moving. So we differentiate the left-hand side and we differentiate the right-hand side. The left-hand side is a product. The right-hand side is not a product. It's a sum of two functions. So here we have sine y plus x cosine y dy over dx. Do we have that? sine y plus x cosine y dy over dx. Equals 1 over x squared minus 2x times the even function prime, which is, we found it?
Yeah, number 8.
Regard y as the independent variable. Fine. And x as the dependent variable. Fine. So then we are looking for dx over dy. I'm gonna copy it and then you can look yourself up.
Okay, thank you.
So let me copy it. I'm
Okay.
gonna copy it on the next page.
It'll be 2x.
So we have x cubed y squared minus x to the fourth y plus 2xy cubed equals 0. Perfect. Now you can log out. Okay, so let's work on this problem. So the left-hand side prime, the right-hand side prime. So x prime is 1, so we have sine y plus x. We differentiate sine, and it's cosine y and dy over dx equals. Now the other side is 1 over x squared minus 2x times 2x minus 2. Do you agree so far? And plus, we bring down 3, 12 y squared dy over dx. Is this okay, everyone? Yes? Is this okay? We see two terms having the variable. This term and that term. I'm gonna bring that one to the left. I'm gonna take this one to the right. So x cosine y, but minus this times dy over dx. So these are accounted for. Now I keep this as a fraction as 2x minus 2 over x squared minus 2x, and I bring this over. Is that okay? And the final step would be divide both sides by all this. In order to find dy over dx, this is in the denominator, x cosine y minus 12y squared, and this is at the top, 2x minus 2 over x squared minus 2x minus sine y. And you can leave it as it is. Any questions, everyone? Any questions? Okay. So this one requires work. It requires factoring and simplifying. And it says fully simplify the final answer. Oh, I'm sorry. You'll see when you get to my age, you are going to forget to. We have this problem. Sorry. Okay. This time we are asked to find dx over dy, which means x is a function of y. So x is the function and y is the variable. So we want to differentiate. Product. We have to apply the product rule 3 times. The first function prime, remember x is the function. This and this and this, these are the function x. Okay, so 3x squared dx over dy times y squared plus x cubed times 2 times y minus. Y is the variable, so when I differentiate x cubed, I get 3x squared times dx over dy times y squared plus x cubed times y squared. Y is the variable, it's just 2y. Done. Minus. I continue with the second one. Since I will run out of room, I'll continue here. The fact that I write minus twice, it doesn't mean that it's two negatives and it turns into a positive. It just means that this ends here. Follow for the next, look for the next step. It has to start with the same thing. So minus. Be very careful because now we have to distribute the negative sign. So I have 4x to the third, but dx over dy times y. And plus x to the fourth. Because when I differentiate y being the variable, y prime is 1. Now we reach the last product, plus. Leave 2 outside, don't even bother with it. You can wait. The first function prime would be dx over dy times y cubed plus x times 3 times y squared equals 0. One more time, the last product. 2, x prime is dx over dy, y cubed is y cubed, plus x times 3 times y squared, because y is the variable, not the function. So now I have to remove some parentheses here. I'm going to condense. So this I'm going to condense into 3x squared y squared dx over dy. This is positive 2x cubed y. This, careful, is minus 4x cubed y dx over dy. And minus x to the fourth plus 2y cubed dx over dy plus 6x y squared equals 0. The variable is this. All the terms having this quantity have to stay on one side. This will go to the other side, and this will go to the other side. Yes, Hans, go ahead.
So like, why do you stick the x over dy like at that specific place?
You mean instead of writing x prime?
No, but
Why did
usually
we-
when I do a product rule, I don't put in dx over dy. I still can get the answer, but sometimes you put it in under like what or when do you put it in?
When I use this differentiation, I always use dy over dx.
Like over there it's 3x squared to y squared, and then you multiply by dx over dy. Like, but why do you like put it?
It's like for the derivative of y, when you take the derivative of y, you put that there. Instead of, because if you take the derivative of x, you're pretty much saying dx over dx, which is 1, so you don't have to write it.
Oh, okay. Okay. That's why I didn't find the second one. Okay.
I hear what you just said. But as long as Han understood, it's
I
fine.
didn't explain it.
So, one more time. In this particular problem, we are told x is the function. So there is a function that is x of y. So x is the function, y is the variable, the independent variable. So every time I differentiate x now, I have to write dx over dy. When I differentiate y, I don't have to write that, because y is the variable in this problem. It should have been x. They are reversed. They are just checking whether we have a good understanding of this. And they reversed x and y. So that's why when I differentiate this product, I have 3x squared times the function prime. Because it's x. X is the function. That's why I highlighted it so I don't forget myself. Times y squared, and then plus, when I differentiate y squared, I only have 2y. Not times dy over dx, because that is the independent variable. This is like differentiating x squared. It's 2x. But this time, y squared prime is 2y, because that's the question. Better?
Yeah.
Okay,
It's originally like dy over dx.
correct.
instead of
But
dx
this
over
time they're telling us, careful, x is the function, y is the independent variable.
Right, yeah.
They're reversing them. Okay, so now I will factor out dy over dx over dy from three terms. From here I get 3x squared y squared. From here I get negative 4x cubed y. And from here I get 2 plus 2y cubed. On the other side, I will have x to the fourth minus 2x cubed y and minus 6xy squared. I put this one first because it's positive, then I'll move this one to negative and this one is negative. So then finally dx over dy is x to the fourth minus 2x cubed y minus 6xy squared over all this. 3x squared y squared minus 4x cubed y plus 2y cubed. Is this better?
Absolutely, yeah. Thank you.
Okay, other questions on this? Okay, perfect. So now we continue with this one. We had something similar because this is so important. So it's y equals 2x minus 5 cubed over 3x plus 4 to the fourth. So let's work on this, please.